Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Data Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
You have created an external table for Apache Hive partition data that resides in a cloud storage bucket, which contains a large number of files. You notice that queries against this table are slow. You want to improve the performance of these queries. What should you do? The options are: Option A, change the storage class of the Hive partition data objects from coldline to standard. Option B, create an individual external table for each Hive partition by using a common table name prefix. Use wildcard table queries to reference the partition data. Option C, upgrade the external table to a Big Lake table. Enable metadata caching for the table. Option D, migrate the Hive partition data objects to a multi-region cloud storage bucket.
To arrive at the correct answer, we focus on the keywords: external table, Apache Hive partition data, cloud storage bucket, large number of files, queries against this table are slow, improve the performance.
The correct answer is option C, upgrade the external table to a Big Lake table. Enable metadata caching for the table.
Why is this correct? C. Upgrading the external table to a Big Lake table and enabling metadata caching significantly improves query performance. It caches file metadata, reducing the need for expensive list operations on buckets with a large number of files during query execution. Why are the others incorrect? A. The storage class of cloud storage objects affects storage costs and retrieval pricing, but it does not dictate BigQuery's query execution performance on the data. B. Creating individual tables for each partition and using wildcard queries is an anti-pattern. It increases management overhead and fails to utilize native partitioning benefits, which can actually worsen performance. D. Migrating data to a multi-region bucket improves availability and geographic redundancy, but it does not address the performance bottleneck associated with metadata retrieval from a large number of files.
You have a network of 1,000 sensors. The sensors generate time series data, 1 metric per sensor per second, along with a timestamp. You already have 1 terabyte of data, and expect the data to grow by 1 gigabyte every day. You need to access this data in 2 ways. The first access pattern requires retrieving the metric from one specific sensor stored at a specific timestamp, with a median single-digit millisecond latency. The second access pattern requires running complex analytic queries on the data, including joins, once a day. How should you store this data? The options are: Option A, store your data in BigQuery. Concatenate the sensor ID and timestamp, and use it as the primary key. Option B, store your data in Bigtable. Concatenate the sensor ID and timestamp and use it as the row key. Perform an export to BigQuery every day. Option C, store your data in Bigtable. Concatenate the sensor ID and metric, and use it as the row key. Perform an export to BigQuery every day. Option D, store your data in BigQuery. Use the metric as a primary key.
To arrive at the correct answer, we focus on the keywords: time series data, retrieving the metric from one specific sensor stored at a specific timestamp, median single-digit millisecond latency, complex analytic queries, joins.
The correct answer is option B, store your data in Bigtable. Concatenate the sensor ID and timestamp and use it as the row key. Perform an export to BigQuery every day.
Why is this correct? B. Bigtable provides single-digit millisecond latency for point reads using a row key combining sensor ID and timestamp. Exporting to BigQuery satisfies the daily complex analytical queries with joins. Why are the others incorrect? A. BigQuery is an analytical data warehouse, not an operational database. It cannot guarantee the median single-digit millisecond latency required for retrieving individual sensor metrics. C. A big table row key must include the timestamp for efficient retrieval based on time. Using the metric instead makes querying for a specific timestamp highly inefficient. D. BigQuery is incapable of providing median single-digit millisecond latency. Additionally, using the metric as a primary key is not a valid or useful schema design for time series data.
You have 100 gigabytes of data stored in a BigQuery table. This data is outdated and will only be accessed 1 or 2 times a year for analytics with SQL. For backup purposes, you want to store this data to be immutable for 3 years. You want to minimize storage costs. What should you do? The options are: Option A, 1. Create a BigQuery table clone. Point 2. Query the clone when you need to perform analytics. Option B, 1. Create a BigQuery table snapshot. Point 2. Restore the snapshot when you need to perform analytics. Option C, 1. Perform a BigQuery export to a cloud storage bucket with archive storage class. Point 2. Enable versioning on the bucket. Point 3. Create a BigQuery external table on the exported files. Option D, 1. Perform a BigQuery export to a cloud storage bucket with archive storage class. Point 2. Set a locked retention policy on the bucket. Point 3. Create a BigQuery external table on the exported files.
To arrive at the correct answer, we focus on the keywords: accessed 1 or 2 times a year, analytics with SQL, immutable for 3 years, minimize storage costs.
The correct answer is option D, 1. Perform a BigQuery export to a cloud storage bucket with archive storage class. Point 2. Set a locked retention policy on the bucket. Point 3. Create a BigQuery external table on the exported files.
Why is this correct? D. Exporting to cloud storage archive class minimizes storage costs for rarely accessed data. A locked retention policy ensures the data remains immutable for 3 years. BigQuery external tables allow analytics with SQL directly on the exported files. Why are the others incorrect? A. BigQuery table clones do not provide immutability, and keeping the data in BigQuery storage does not minimize costs compared to cloud storage archive class. B. BigQuery table snapshots provide backups but do not guarantee strict immutability against deletion for 3 years, and they cost more than GCS archive storage. C. Object versioning does not enforce immutability, it only retains previous versions upon modification or deletion. A locked retention policy is required to guarantee data immutability.
You have thousands of Apache Spark jobs running in your on-premises Apache Hadoop cluster. You want to migrate the jobs to Google Cloud. You want to use managed services to run your jobs instead of maintaining a long-lived Hadoop cluster yourself. You have a tight timeline and want to keep code changes to a minimum. What should you do? The options are: Option A, move your data to BigQuery. Convert your Spark scripts to a SQL-based processing approach. Option B, rewrite your jobs in Apache Beam. Run your jobs in Dataflow. Option C, copy your data to compute engine disks. Manage and run your jobs directly on those instances. Option D, move your data to cloud storage. Run your jobs on Dataproc.
To arrive at the correct answer, we focus on the keywords: Apache Spark jobs, migrate the jobs to Google Cloud, use managed services, instead of maintaining a long-lived Hadoop cluster, tight timeline, keep code changes to a minimum.
The correct answer is option D, move your data to cloud storage. Run your jobs on Dataproc.
Why is this correct? D. Dataproc is a fully managed service for Apache Spark and Hadoop. Storing data in cloud storage and using Dataproc allows existing Spark scripts to run natively with minimal code changes, satisfying the tight timeline and avoiding long-lived cluster maintenance. Why are the others incorrect? A. Converting Spark scripts to BigQuery SQL requires significant rewriting, which violates the requirement to keep code changes to a minimum. B. Rewriting existing jobs in Apache Beam for Dataflow involves extensive code changes, contradicting the goal of minimizing code changes on a tight timeline. C. Running jobs directly on compute engine instances requires you to maintain the cluster yourself, violating the requirement to use managed services.
You are administering shared BigQuery datasets that contain views used by multiple teams in your organization. The marketing team is concerned about the variability of their monthly BigQuery analytics spend using the on-demand billing model. You need to help the marketing team establish a consistent BigQuery analytics spend each month. What should you do? The options are: Option A, create a BigQuery enterprise reservation with a baseline of 250 slots and autoscaling set to 500 for the marketing team, and bill them back accordingly. Option B, establish a BigQuery quota for the marketing team, and limit the maximum number of bytes scanned each day. Option C, create a BigQuery reservation with a baseline of 500 slots with no autoscaling for the marketing team, and bill them back accordingly. Option D, create a BigQuery standard pay-as-you-go reservation with a baseline of 0 slots and autoscaling set to 500 for the marketing team, and bill them back accordingly.
To arrive at the correct answer, we focus on the keywords: variability of their monthly BigQuery analytics spend, on-demand billing model, establish a consistent BigQuery analytics spend each month.
The correct answer is option C. Create a BigQuery reservation with a baseline of 500 slots with no autoscaling for the marketing team, and bill them back accordingly.
Why is this correct? C. Setting a reservation with a fixed baseline of slots and no autoscaling provides capacity pricing with a completely predictable and consistent monthly cost, eliminating variability. Why are the others incorrect? A. Enabling autoscaling introduces variable costs based on usage, which fails the requirement for a consistent monthly spend. B. Setting a daily quota limits the maximum usage but does not prevent variability or guarantee a consistent monthly spend. D. A baseline of 0 slots with autoscaling to 500 operates essentially on a pay-as-you-go basis, resulting in variable monthly costs.
You are part of a healthcare organization where data is organized and managed by respective data owners in various storage services. As a result of this decentralized ecosystem, discovering and managing data has become difficult. You need to quickly identify and implement a cost-optimized solution to assist your organization with the following: data management and discovery, data lineage tracking, data quality validation. How should you build the solution? The options are: Option A, use BigLake to convert the current solution into a data lake architecture. Option B, build a new data discovery tool on Google Kubernetes Engine that helps with new source onboarding and data lineage tracking. Option C, use BigQuery to track data lineage, and use Dataprep to manage data and perform data quality validation. Option D, use Dataplex to manage data, track data lineage, and perform data quality validation.
To arrive at the correct answer, we focus on the keywords: decentralized ecosystem, data management and discovery, data lineage tracking, data quality validation.
The correct answer is option D. Use Dataplex to manage data, track data lineage, and perform data quality validation.
Why is this correct? D. Dataplex is a managed data fabric that centralizes management for decentralized data. It natively provides unified data discovery, automatic data lineage tracking, and built-in data quality validation without moving data. Why are the others incorrect? A. BigLake unifies storage access but lacks native, out-of-the-box comprehensive features for automated data lineage tracking and data quality validation. B. Building a custom tool on GKE is not cost-optimized and requires significant development and maintenance overhead compared to a fully managed service. C. BigQuery lacks native enterprise-wide lineage tracking for decentralized systems, and Dataprep is a data preparation tool, not a centralized data management and discovery platform.
You have data located in BigQuery that is used to generate reports for your company. You have noticed some weekly executive report fields do not correspond to format according to company standards. For example, report errors include different telephone formats and different country code identifiers. This is a frequent issue, so you need to create a recurring job to normalize the data. You want a quick solution that requires no coding. What should you do? The options are: Option A, use Cloud Data Fusion and Wrangler to normalize the data and set up a recurring job. Option B, use Dataflow SQL to create a job that normalizes the data, and that after the first run of the job, schedule the pipeline to execute recurrently. Option C, create a Spark job and submit it to Dataproc serverless. Option D, use BigQuery and Google SQL to normalize the data and schedule recurring queries in BigQuery.
To arrive at the correct answer, we focus on the keywords: recurring job to normalize the data, quick solution that requires no coding.
The correct answer is option A, use Cloud Data Fusion and Wrangler to normalize the data and set up a recurring job.
Why is this correct? A. Cloud Data Fusion with Wrangler provides a visual, code-free interface for data preparation and normalization. It allows you to build and schedule recurring data pipelines without writing any code. Why are the others incorrect? B. Dataflow SQL requires writing SQL queries, which contradicts the requirement for a solution that requires no coding. C. Creating a Spark job involves writing code, such as Python, Scala, or Java, which violates the strict no coding requirement. D. Using Google SQL and BigQuery requires writing SQL code, failing to meet the requirement for a solution that requires no coding.
You are designing a messaging system by using pub/sub to process clickstream data with an event-driven consumer app that relies on a push subscription. You need to configure the messaging system that is reliable enough to handle temporary downtime of the consumer app. You also need the messaging system to store the input messages that cannot be consumed by the subscriber. The system needs to retry failed messages gradually, avoiding overloading the consumer app, and store the failed messages after a maximum of 10 retries in a topic. How should you configure the pub/sub subscription? The options are: Option A, increase the acknowledgement deadline to 10 minutes. Option B, use immediate redelivery as the subscription retry policy, and configure dead lettering to a different topic with maximum delivery attempts set to 10. Option C, use exponential backoff as the subscription retry policy, and configure dead lettering to the same source topic with maximum delivery attempts set to 10. Option D, use exponential backoff as the subscription retry policy, and configure dead lettering to a different topic with maximum delivery attempts set to 10.
To arrive at the correct answer, we focus on the keywords: handle temporary downtime, retry failed messages gradually, avoiding overloading the consumer app, store the failed messages after a maximum of 10 retries in a topic.
The correct answer is option D, use exponential backoff as the subscription retry policy, and configure dead lettering to a different topic with maximum delivery attempts set to 10.
Why is this correct? D. Exponential backoff retries failed messages gradually to avoid overloading. Dead lettering to a different topic safely stores messages after the maximum delivery attempts, 10, to prevent infinite retry loops. Why are the others incorrect? A. Increasing the acknowledgement deadline provides more time for a single processing attempt but does not gradually retry failed messages or store unconsumed messages after 10 attempts. B. Immediate redelivery will retry failed messages without delay, which does not meet the requirement to retry gradually and avoid overloading the consumer app. C. Configuring dead lettering to the same source topic will create an infinite loop where failed messages are continually republished back to the original topic rather than being safely stored.
You designed a data warehouse in BigQuery to analyze sales data. You want a self-serving, low-maintenance, and cost-effective solution to share the sales dataset to other business units in your organization. What should you do? The options are: Option A, create an Analytics Hub private exchange and publish the sales dataset. Option B. Enable the other business units projects to access the authorized views of the sales dataset. Option C. Create and share views with the users in the other business units. Option D. Use the BigQuery data transfer service to create a schedule that copies the sales dataset to the other business units projects.
To arrive at the correct answer, we focus on the keywords self-serving, low maintenance, cost-effective, share the sales dataset to other business units.
The correct answer is option A. Create an Analytics Hub private exchange and publish the sales dataset.
Why is this correct? A. Analytics Hub provides a secure, self-serving, and low-maintenance platform to create private exchanges, enabling cost-effective sharing of BigQuery datasets across internal business units without data duplication. Why are the others incorrect? B. Authorized views are used to share specific query results or restrict row/column access, which is high maintenance and lacks the self-service discovery provided by Analytics Hub. C. Manually creating and sharing views with individual users is a high-maintenance, unscalable approach that does not provide a self-serving catalog for other business units. D. Copying datasets using data transfer service duplicates data, increasing storage costs and maintenance overhead, directly violating the cost-effective and low-maintenance requirements.
You have terabytes of customer behavioral data streaming from Google Analytics into BigQuery daily. Your customers' information, such as their preferences, is hosted on a Cloud SQL for MySQL database. Your CRM database is hosted on a Cloud SQL for PostgreSQL instance. The marketing team wants to use your customers' information from the two databases and the customer behavioral data to create marketing campaigns for yearly active customers. You need to ensure that the marketing team can run the campaigns over 100 times a day on typical days and up to 300 during sales. At the same time, you want to keep the load on the Cloud SQL databases to a minimum. What should you do? The options are: Option A. Create BigQuery connections to both Cloud SQL databases. Use BigQuery federated queries on the two databases and the Google Analytics data on BigQuery to run these queries. Option B. Create a job on Apache Spark with Dataproc serverless to query both Cloud SQL databases and the Google Analytics data on BigQuery for these queries. Option C. Create streams in DataStream to replicate the required tables from both Cloud SQL databases to BigQuery for these queries. Option D. Create a Dataproc cluster with Trino to establish connections to both Cloud SQL databases and BigQuery to execute the queries.
To arrive at the correct answer, we focus on the keywords Google Analytics into BigQuery, Cloud SQL for MySQL database, Cloud SQL for PostgreSQL instance, run the campaigns over 100 times a day, keep the load on the Cloud SQL databases to a minimum.
The correct answer is option C. Create streams in DataStream to replicate the required tables from both Cloud SQL databases to BigQuery for these queries.
Why is this correct? C. DataStream efficiently replicates data from Cloud SQL to BigQuery. Querying the replicated data directly in BigQuery isolates analytical workloads, satisfying high query frequency requirements while ensuring the load on the transactional databases is kept to a minimum. Why are the others incorrect? A. BigQuery federated queries push the query execution down to the Cloud SQL instances. Running hundreds of queries daily would significantly increase the load on the source databases, violating the core requirement. B. Querying Cloud SQL databases directly via Dataproc serverless, Apache Spark, increases the load on the transactional databases during execution, violating the requirement to keep load to a minimum. Why are the others incorrect? D. Using a Dataproc cluster with Trino to query the Cloud SQL databases directly would place a high analytical load on the source databases, violating the minimal load requirement.
Your organization is modernizing their IT services and migrating to Google Cloud. You need to organize the data that will be stored in cloud storage in BigQuery. You need to enable a data mesh approach to share the data between sales, product design, and marketing departments. What should you do? The options are Option A, 1. Create a project for storage of the data for each of your departments. Point 2. Enable each department to create cloud storage buckets and BigQuery datasets. Point 3. Create user groups for authorized readers for each bucket and dataset. Point 4. Enable the IT team to administer the user groups to add or remove users as the departments request. Option B, 1. Create multiple projects for storage of the data for each of your department's applications. Point 2. Enable each department to create cloud storage buckets and BigQuery datasets. Point 3. Publish the data that each department shared in Analytics Hub. Point 4. Enable all departments to discover and subscribe to the data they need in Analytics Hub. And the remaining options are Option C, 1. Create a project for storage of the data for your organization. Point 2. Create a central cloud storage bucket with 3 folders to store the files for each department. Point 3. Create a central BigQuery dataset with tables prefixed with the department name. Point 4. Give viewer rights for the storage project for the users of your departments. Option D, 1. Create multiple projects for storage of the data for each of your department's applications. Point 2. Enable each department to create cloud storage buckets and BigQuery datasets. Point 3. In Dataplex, map each department to a data lake and the cloud storage buckets, and map the BigQuery datasets to zones. Point 4. Enable each department to own and share the data of their data lakes.
To arrive at the correct answer, we focus on the keywords, cloud storage, BigQuery, data mesh, share the data.
Review the options on screen. The correct answer is option D, 1. Create multiple projects for storage of the data for each of your department's applications. Point 2. Enable each department to create cloud storage buckets and BigQuery datasets. Point 3. In Dataplex, map each department to a data lake and the cloud storage buckets, and map the BigQuery datasets to zones. Point 4. Enable each department to own and share the data of their data lakes.
Why is this correct? D. Dataplex is specifically designed to build and manage a data mesh architecture across cloud storage and BigQuery, enabling domain-driven ownership and secure data sharing across decentralized departments. Why are the others incorrect? A. Relying on a central IT team to administer access groups contradicts the core data mesh principle of decentralized, domain-driven data ownership. B. Analytics Hub facilitates BigQuery data sharing but does not natively provide a comprehensive data mesh framework that integrates both cloud storage and BigQuery like Dataplex does. C. Using a single central project with central storage structures creates a monolithic architecture, directly violating the data mesh paradigm of distributed data domains.
You work for a large e-commerce company. You are using pub/sub to ingest the clickstream data to Google Cloud for analytics. You observe that when a new subscriber connects to an existing topic to analyze data, they are unable to subscribe to older data. For an upcoming yearly sale event in 2 months, you need a solution that, once implemented, will enable any new subscriber to read the last 30 days of data. What should you do? The options are, Option A, create a new topic and publish the last 30 days of data each time a new subscriber connects to an existing topic. Option B, set the topic retention policy to 30 days. Option C, set the subscriber retention policy to 30 days. Option D, ask the source system to re-push the data to pub/sub and subscribe to it.
To arrive at the correct answer, we focus on the keywords, pub/sub, new subscriber connects to an existing topic, unable to subscribe to older data, enable any new subscriber to read the last 30 days of data.
The correct answer is option B, set the topic retention policy to 30 days.
Why is this correct? B. Setting a topic message retention policy allows pub/sub to retain published messages for a specified duration. This enables any new subscription attached to the topic to read historical data up to that retention period, perfectly fulfilling the 30-day requirement. Why are the others incorrect? A. This approach is highly inefficient and creates unnecessary operational overhead. pub/sub natively supports retaining historical messages, so manually republishing data to a new topic for every new subscriber is an anti-pattern. C. Subscription message retention only applies to messages published after the subscription is created. It does not allow a newly created subscription to access messages that were published to the topic prior to the subscription's existence. D. Asking the source system to repush data requires building custom logic and generates duplicate messages. This is an inefficient workaround, whereas pub/sub's native topic retention feature solves the issue seamlessly.
You are designing the architecture to process your data from cloud storage to BigQuery by using Dataflow. The network team provided you with the shared VPC network and subnetwork to be used by your pipelines. You need to enable the deployment of the pipeline on the shared VPC network. What should you do? The options are: Option A, assign the compute.network user role to the Dataflow service agent. Option B, assign the compute.network user role to the service account that executes the Dataflow pipeline. Option C, assign the Dataflow.admin role to the Dataflow service agent. Option D, assign the Dataflow.admin role to the service account that executes the Dataflow pipeline.
To arrive at the correct answer, we focus on the keywords: Dataflow, shared VPC network and subnetwork, deployment of the pipeline on the shared VPC network.
Correct answer is option B, assign the compute.network user role to the service account that executes the Dataflow pipeline.
Why is this correct? D. To deploy a Dataflow pipeline on a shared VPC network, the worker's service account that executes the pipeline must be granted the compute.network user role. Why are the others incorrect? A. The compute.network user role is required for the service account executing the pipeline, worker service account, not the Dataflow service agent. C. The Dataflow.admin role allows management of Dataflow jobs but does not grant the required network permissions for shared VPC usage. D. While Dataflow.admin manages Dataflow jobs, it does not provide the compute.network user permissions needed to use a shared VPC subnetwork.
Your infrastructure team has set up an interconnect link between Google Cloud and the on-premises network. You are designing a high-throughput streaming pipeline to ingest data in streaming from an Apache Kafka cluster hosted on-premises. You want to store the data in BigQuery with as minimal latency as possible. What should you do? The options are: Option A, set up a Kafka Connect bridge between Kafka and pub/sub. Use a Google-provided Dataflow template to read the data from pub/sub and write the data to BigQuery. Option B, use a proxy host in the VPC in Google Cloud connecting to Kafka. Write a Dataflow pipeline, read data from the proxy host, and write the data to BigQuery. Option C, use Dataflow, write a pipeline that reads the data from Kafka and writes the data to BigQuery. Option D, set up a Kafka Connect bridge between Kafka and pub/sub. Write a Dataflow pipeline, read the data from pub/sub, and write the data to BigQuery.
To arrive at the correct answer, we focus on the keywords: interconnect link, high-throughput streaming pipeline, ingest data in streaming from an Apache Kafka cluster, store the data in BigQuery, minimal latency as possible.
Correct answer is option C, use Dataflow, write a pipeline that reads the data from Kafka and writes the data to BigQuery.
Why is this correct? C. Dataflow can directly connect to the on-premises Kafka cluster over the interconnect link using the Kafka I/O connector, providing the most direct path and minimizing latency. Why are the others incorrect? A. Adding pub/sub as an intermediary step adds unnecessary hops and latency to the pipeline, contradicting the requirement for minimal latency. B. A proxy host is unnecessary since the interconnect link already provides direct connectivity, and adding a proxy would introduce additional latency and management complexity. D. Similar to A, introducing a Kafka Connect bridge in pub/sub adds unnecessary intermediate steps that increase latency compared to reading directly with Dataflow.
You migrated your on-premises Apache Hadoop Distributed File System (HDFS) data lake to cloud storage. The data scientist team needs to process the data by using Apache Spark and SQL. Security policies need to be enforced at the column level. You need a cost-effective solution that can scale into a data mesh. What should you do? The options are: Option A, 1. Deploy a long-living Dataproc cluster with Apache Hive and Ranger enabled. Point 2. Configure Ranger for column-level security. Point 3. Process with Dataproc Spark or Hive SQL. Option B, 1. Define a big lake table. Point 2. Create a taxonomy of policy tags in data catalog. Point 3. Add policy tags to columns. Point 4. Process with the Spark BigQuery connector or BigQuery SQL. Option C, 1. Load the data to BigQuery tables. Point 2. Create a taxonomy of policy tags in data catalog. Point 3. Add policy tags to columns. Point 4. Process with the Spark BigQuery connector or BigQuery SQL. Option D, 1. Apply an identity and access management (IAM) policy at the file level in cloud storage. Point 2. Define a BigQuery external table for SQL processing. Point 3. Use Dataproc Spark to process the cloud storage files.
To arrive at the correct answer, we focus on the keywords: data lake to cloud storage, Apache Spark and SQL, column level, cost-effective, scale into a data mesh.
The correct answer is option B, 1. Define a big lake table. Point 2. Create a taxonomy of policy tags in data catalog. Point 3. Add policy tags to columns. Point 4. Process with the Spark BigQuery connector or BigQuery SQL.
Why is this correct? B. Big Lake tables support column-level security using data catalog policy tags on cloud storage data. It avoids data duplication, is cost-effective, and integrates with Spark and BigQuery for a data mesh. Why are the others incorrect? A. Deploying a long-living Dataproc cluster incurs continuous infrastructure costs, making it a less cost-effective solution than serverless or managed alternatives like Big Lake. C. Loading data directly into BigQuery tables duplicates data storage and increases costs, whereas Big Lake can query cloud storage data in place. D. IAM policies in cloud storage can only be applied at the bucket or file, object, level, not at the column level required by the security policies.